Hello, this is Jeff Hamrick again at Rhodes College, and I'm going to talk with you about executing a two-sample, an independent samples t-test in SPSS. I've already imported into SPSS the body temperature and resting heart rate data that we've been using throughout the semester. These data are separated by gender, so it is set up naturally for us to ask ourselves questions like, do men and women have different average body temperatures? Do men and women have different or similar average resting heart rates? The important thing about doing the independent samples t-test in SPSS in terms of the setup of the data is to make sure that the grouping variable, that is the dichotomous variable that indicates who's in group number 1 and who's in group number 2, is a column. So you cannot have a column like this with resting heart rate data for women and another column like this that has resting heart rate data for men. You've got to have a single column called gender that splits apart who's a male case, who's a female case. All right? If your data is set up in this way, then you're ready to proceed with an independent samples t-test. And here's how you do that. You click on Analyze, Compare Means, and you do the independent samples t-test option. Okay? I've already moved over here in the wizard body temperature and heart rate into the test variables column. And notice that in SPSS you have to define a grouping variable. So if I move this back over here and I move it back, gender is our grouping variable. You have to always tell SPSS how it is to perceive which members are in which group. And because a grouping variable could have many different categories, let's say Asian, Black, Latino, white, you have to tell SPSS which groups it is that you would like to compare to one another. So in this case, it's very unambiguous. We have just males and just females. So I define the groups in SPSS as male and female, respectively. You have to type that in there. So press continue, and then you can use options once again to change the confidence level for the confidence interval that will be created for the true difference in male and female body temperatures. Let's say we want a 95% confidence interval. Press continue and then OK. And then SPSS will generate output for you. Let's talk about it briefly. This is your summary statistical information associated with the analysis. It has run a hypothesis test both on whether or not men and women have the same body temperature and whether or not men and women have the same resting heart rate on average. So in this class, you should always read the second row here. Equal variance is not assumed. We will always assume that our two separate groups do not necessarily have variances that are equal. Now in this case it turns out not to matter very much, because if we look over here at the student t-test statistic, it's the same for both choices in both cases of body temperature and resting heart rate. So it sometimes doesn't matter, but we want you to be particularly careful to always read the second row right here. You can ignore this thing called Levene's test for the equality of variances, and I want you to be careful about this quantity called degrees of freedom. Remember that SPSS is using the Satterthwaite approximation that is often going to produce for it a decimal degrees of freedom rather than an integer degrees of freedom. For hand calculations in this class, for the two-sample t-test, we've said that the degrees of freedom will be equal to the minimum of the two separate group sample sizes minus 1. Okay? This is considerably larger than that, but SPSS is going to follow a slightly different protocol than we will with hand calculations. We have p-values here. They have been doubled because the assumption is that the alternative hypothesis is that mu1 is not equal to mu2. If you want to run a one-tailed hypothesis, alternative hypothesis, you need to have these sig two-tailed figures. But because this sig two-tailed is less than 5%, we would reject the null hypothesis that men and women have the same mean body temperature. Because this is well in excess of 0.05, we would not reject the null hypothesis that men and women have the same mean resting heart rates. Here are the confidence intervals for the true difference in male and female body temperatures and resting heart rates, respectively. So that, my friends, is how you execute a two-sample, an independent samples t-test in SPSS.